is a measure of the rate at which work is being done. The formula of power, P equal W over T. The SI unit for power is the watt, where 1 watt equals 1 joule. Because work is energy transfer, power is also the rate at which energy is expended. A 60 watt light bulb, for example, expends 60 joule of energy per second. Great power means a large amount of work or energy developed in a short time. For example, when a powerful car accelerates rapidly, it does a large amount of work and consume a large amount of fuel in a short time. The energy of a body is a measure of the capacity which the body has to do work.
Hi, Assalamualaikum. My name is Muhammad Hakimin Suhaimi. So I will be talking about what is the question. So the question is, what is the power output for a 64 kilogram man who runs up a 3-meter high flight of stairs in 4 seconds, starting from rest but having a final speed of 1.2 meter per second? So let's find out.
The work going into mechanical energy is W equal KE plus PE. At the bottom of the stairs, we take both KE and PE as initially 0, thus the equation below, where H is the vertical height of the stairs. Because all terms are given, we can calculate W and then divide it by time to get power.
Assalamualaikum warahmatullahi wabarakatuh. My name is Akila binti Zafaka and I'll be calculating the solution from the question below, from the question before. So before we calculate, we need to list out all of the information given from the question. As we can see from the question that the mass of this guy is 64 kilogram and the height of the stair is 3 meter. So it is given that the guy start from rest, which is U, will equivalent to 0, and it also have a final speed, which is V is equal to 1.25 meter per second. So as you can see from the video, when this man runs upstairs starting from rest, he converts the chemical energy originally from food into kinetic energy and gravitational potential energy. His power output depends on how fast he does this. So the question said, what is the power output? Formula of the power is equal to work done. So work done is equivalent to kinetic energy plus potential energy. First, we have to calculate kinetic energy. The formula of the kinetic energy is 1 over 2 mv squared. So just substitute from the list that we have listed out before, which is 1 over 2 times mass, which is 64, and then times with V, which is 1.25 squared. And when you calculate, you will get 50 joules. And then you have to calculate the potential energy, which is the formula is equal to mgh. Just substitute into the formula, which is 64 times the gravitational, which is 9.8, and the height of the stair is 3 meter, and you will get 1881.6 joules. And then continue, which is The formula of work done is kinetic energy plus potential energy. So we have calculate the kinetic energy and potential energy. So we just add it up, which is 50 joule plus 1881.6 joule, and then you will get 1931.6 joule. So we need to calculate the rate of working of the guy running up the stair, which is the formula is work done over time. So just substitute to the formula, which is 1931.6 joule divide with the time taken of the guy running upstairs, which is 4 seconds, and then you will get 482.9 watt. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and hi everyone, my name is Nisa Nashaira binti Norishkanda. My number is student 950609 and I'm from CS1434A. Moving on to the discussion, the man does 1881.6 joule of work to move up the stairs compared with only 15 joule to increase his kinetic energy. Hence, most of his power output is required for climbing rather than accelerating. In conclusion, when you climb stairs, you do work on your mass and increase your potential energy. The amount of work you do is equal to the change in your potential energy. Power is the rate at which work is done. If you climb the stairs quickly, you operate at a high power level. So that's all from me. Thank you.